It's Wednesday, the 19th of September. My name is Juan Brown. You're watching the Blanco Lirio channel, and it's time for a very special boots on the ground return to Oroville Spillway for a detailed report on construction to date on the Oroville main spillway and emergency spillway. Let's check it out. It's 19th September 2018. I'm in the car with Jeff Petersen of Kiewit Engineering and Erin Mellon from DWR. We're going to go take a look at the Oroville project. Let's check it out. I think we'll start this tour off at the top with Project Director Todd Orbis, who can help explain how they keep a project of this magnitude on schedule and organized. Some historic photos, some recent photos.
Yeah, we did a board that showed, when we started.
Little time lapse.
Time lapse
yeah.
every week. For this is last season.
And this is when it was originally constructed.
Yep.
The dates on that? 66. Okay. Uh-huh.
And then this is this season's time lapse.
Uh-huh. The 18, yeah. That's right.
Juan, you're famous here.
Yeah, I am, apparently, but he's asking, who's that guy?
Everybody knows.
Oh, man.
Yeah, we can come in the back door here on the other one. I'll show you. So we hold, the main meeting we hold in here is called our Play of the Day meeting. Mm-hmm. We have it every day at 1 o'clock. And each discipline will go through what they're planning to do for night shift and then the next day. And so every one of these boards is basically a different zone of the project and a different superintendent's in charge of it. And so that's what these guys are in here updating their board for our meeting that we got in 20 minutes, and we sit down and roll through it. Mm-hmm. That's how we manage it on a daily basis. Mm-hmm. And then up front here, we've got a rolling 3-week schedule.
Is this the AM shift over here on the left and PM over on the right?
The civil crews are on that side and the structures crews are on this side.
Okay.
And then on this board, we've got it divided by region of the spillways, different spillways. So this is the upper part of the spillway, and then everybody, this schedule rolls. So today's date is here. So we slide this here.
Yeah.
It starts from here forward and then rolls back to the couple weeks prior, and manage the 3-week schedule using this tool here. And then we actually produce it on a electronic format as well, so it's easier to share around. But how we track our progress every single day.
Mm-hmm.
42 days left.
40. So is that what we're counting down here?
Yeah.
November 1st.
Wow, the big countdown clock. Very interesting. So who figures all this out? Does each individual crafts got to figure out their section of the puzzle and then come together with you guys?
Yeah, there's a discipline manager for each. So for civil, there's a Dave's the construction manager. You just met Dave. Ethan's standing there. He's the structures manager. And then these guys all superintendents that work for him. And then there'll be a civil manager named Josh Domi that'll be in here in a little bit that manages the civil work. You know, and then there's a plant manager too for the batch plants and the crushing. So those guys are all individually responsible. And we've got an overall job schedule. We've got a 90-day look-ahead schedule. We've got a 3-week, and then we got the daily. That's how we do it.
And that's a whole discipline in itself, is the figuring out of this scheduling, right? I mean, that's a full-time job for somebody.
It works two ways. Like schedulers will tell you the milestones that we have to make. This job's pretty simple. Get done by November 1st. And then the discipline managers come in and they also say how long something's going to take. So you have to work back and forth to make it fit. And then structure guys can't finish their work until the grading guys get their work done. So a lot of coordination amongst all the managers to achieve the schedule milestones.
The spillway, the whole length of the spillway plotted up on this whiteboard. And the gate structure's here.
There.
And then they broke it in half just because it's so long, and the terminal structure's here. So if it's blank, it was completed last year. If it's green, it's what we're going after this year. So in the middle and lower sheet, you can see what we have remaining. You already saw it out in the field there, and then if it's got a date in it, it's happening this week. And then in the upper chute, same drill is blank spots is what's remaining for this season.
And the walls are down here on the
Yeah, the very outside edge. So there's a wall there. That's the one you were up on, I think. Is that right?
Next two.
Yeah.
We went right
Yeah,
to
I
the
didn't,
foot of it.
Oh, you didn't go up. Okay.
I didn't climb up that dang thing.
Scott was braver than you, I guess. Yeah, and this is the plan. So this is a graphical representation of the same thing. And
There it is, all the squares filled by November.
Yep. And then these are commodity curves, like the way to track the same information just on a weekly basis with how many cubic yards of concrete. For red is last season, blue is 2018 season, and then these are the cumulative lines and how many we're doing each week. So pushed 7,000 yards one week was our biggest week this season.
And that indicates that you've gotten more work done this year than last year.
Yes, it does.
Don't let Todd's cool demeanor fool you. It's a stressful position, managing over 700 employees in a race against time to meet the demanding, accelerated schedule. Now let's leave the offices behind, which are located up on the upper boat ramp by the emergency spillway, and head up back to the top of the spillway and answer a viewer question about what do the flags mean in the middle of the spillway. At the top of the dam here with Jeff Petersen, one of the questions that came up was, what's up with the flags?
Yeah, the flags denote the safety zones for the cranes on each side of the spillway. So the red flags down the middle are the middle of the spillway, and so the cranes on either side can't. They're not supposed to take a load across that unless they have guidance from the crane observer. So we have a dedicated crane observer at different zones down the spillway. So if they have to cross that safety zone, they get permission, and then they get special spotting, make sure that they don't cross. If they cross that zone, then their booms could impact each other, and that's not good. So it's a visual safety zone that triggers another safety spotting zone.
Specifically for the cranes and crane operators.
Exactly.
Gotcha.
Another viewer asked about the varying heights of the spillway walls.
Another question was the wall heights get shorter as the spillway gets towards the bottom. That's because of the velocity of the water?
Yeah, that's correct. They're the tallest is about 34 feet tall right up here close to the spillway, and at the bottom they're about 22 feet tall. And as the water speeds up, it's flatter and not as deep, so they don't need to be as tall.
And that water velocity is pretty fast towards the bottom, huh?
Yeah, I don't know exactly. I think it's going approximately 90 miles an hour when it's full force and they open up the spillway all the way.
Even though the spillway has a design capability of 300,000 CFS, operationally the spillway has never run harder than 160,000 CFS to protect the integrity of the levees downstream.
So by the end of October, what do we expect to see here?
Yeah, by the end of October, all the concrete work will be placed on this in the entire chute. So all the slabs will be filled in, all the walls will be done. We'll be moving equipment out on November 1st. We'll be finishing the joint sealant and the dry finish on the walls. Probably see some more wall backfill activity progressing, but all the concrete will be done, so the spillway would be ready to use December 1st if they need to.
And so the walls will be backfilled. You're going to be covering the drain pipes along the side of the walls with backfill.
We'll be working on that. It'll go through the winter as weather permits and into early next year.
And slab placement looks good right now to meet that schedule?
Yeah, everything's going good. The middle chute's ahead of schedule. It'll be done this week, and everything up here will be done by the end of October.
And how many folks you got working right now?
There's on the Kiewit team, there's about 710 people, including 100 subcontract employees and 120 staff employees. And then the rest, carpenters, operators, laborers, iron workers.
Where are you finding most of your laborers for this job?
Most of them come from the Northern California counties right around here. There's a few carpenter expert type guys that followed us up from some of the deeper Bay Area. We have a few people come as far away from Alaska, Colorado that hear about the job and work for us in different places in the U.S. But I'd say the majority of them are all from the NorCal vicinity.
Area. And then Erin, do you know, with all these laborers, with all these laborers here on the job, do you know where are they staying? Where are they staying
while they're working on it? Yeah. Where are they staying and eating?
How's that impacting the local economy, folks are asking?
I mean, that'd be a good question for the chamber, but I think that most of the hotels are pretty full right now.
Yeah.
I mean, with the number of folks from Kiewit and the subcontractors and then DWR and our outside experts, I mean, most of the restaurants and the hotels and the casinos have seen us in our gear.
This is the inlet to the gates to the Oroville Spillway. It's a rock structure. There's not going to be much work done onto here. It doesn't need any work because as long as you have an operational spillway, you don't risk any scouring or damaging of this section of the project. Right now, of course, it's a great place to park men and equipment and get equipment in and out through the gates. So Erin, what are we looking at lake level here?
The lake level right now is at elevation 724 feet, which means that there's 1.4 or 5 million acre feet in the reservoir, leaving about 2 million acre feet in flood capacity storage.
And how low should we see it come down to this year?
Like last year, we're targeting an elevation of about 700 feet by November 1st, and that's really important because we want to make sure that we have adequate space in the reservoir to handle any big storms that we may see while the spillway is under construction. And then once the spillway is finished after November 1st, then we'll see the lake levels rise.
And you're going to have a whole new lake operations plan specifically designed for this next year's flood season. They're still working on that, finalizing that?
That's right. That should be finalized later this fall. We've been operating under kind of temporary operations plans with the Army Corps, and then once the full construction is complete, we will be evaluating a new flood control operations manual.
An entire new manual for the entire operation of this.
Yeah, it's part of what we're doing in the comprehensive needs assessment that you've heard about, which is looking at all of the facilities and structures within the Oroville facility, and the flood operations manual being one of those.
Yep, that's a big deal. Great,
Yeah.
Thanks.
This event at Oroville is not only rewriting the book of how we manage the Oroville Reservoir, but it's also rewriting the book for how we manage much of our flood infrastructure up and down the state of California and across the nation. Now we'll talk to Jeff about the buttress wall design for the emergency spillway.
So I see the purple anchor rods are where the buttress is going to tie in with the original OG spillway wall right here?
Yep, that's correct. And then on top of the buttress will be a cap of concrete made from the erosion-resistant concrete, same as the main spillway, will be right on top of it, a little triangle-shaped hat.
So we won't see this nice airfoil shape top anymore?
It'll be airfoil on the top to another airfoil concrete cap.
Okay.
Very similar to the concrete weir that's on the very far distance. And then the water would go down and hit the splash pad, and the splash pad will look just like it does in the first 2/3 that we finished. And we're bringing this last phase up here 1 foot at a time. Right now, it's the final stage of the emergency spillway RCC.
And we talked about the RCC itself on the emergency spillway does not get a hardened treatment, and it doesn't really need one because of the stair-step nature and the impact of the impingement of the water.
Yeah, that's the way the designers have it set up, exactly.
And so the stair-step adds aeration, helps break up the flow, slow it down, and eases the pressure on the concrete, I suppose.
Yep, that's my understanding also.
Yeah. And we're feeding it into 2 low areas. We'll go take a look at that later. And that's still the RCC plant we're looking at right there.
That's correct, yeah.
Hey, you got that back up and running?
Back up and running, everything's good. Everything's running great.
And so did you have to do a green cut to reliven the joint there when you took that break?
Yeah, and the way we stopped it, you can see in the distance where it's just a 1-to-1 slope alongside where the pickups are, and we leave it as a roughened surface.
Gotcha.
So we can just hit it with a pressure washer and get a good joint for the next lift to take place.
Oh, okay, I see. So you built, it's like a scarf joint, basically.
Yep, exactly.
Brilliant.
Yeah, same thing we can see right below us, because we had to fill this in to maintain our road. This actually goes down about, I don't know, almost 50 feet into the very bottom of that hole to tie into competent rock. So we built that phase of RCC ahead of the rest. We'll tie the main RCC splash pad into this abutment of RCC where the left berm will be when we're complete. You can see the shape of the berm starting here down below at the bottom of the spillway.
And so that berm is going to be the edge of the emergency spillway.
Yep,
as it
correct.
approaches the main spillway here.
Yep, there's one on both sides of the emergency spillway.
Gotcha. All right.
The emergency spillway is just that, only to be used in the event of an emergency. If the water level ever exceeds 901 feet MSL, the water will simply pour over the top of the OG weir and down the new splash pad and be drained into 2 low natural drainage spots and eventually down the rest of the dirt hillside to the Thermalito diversion pool below. At the lower end of the splash pad is a Secant cutoff wall extending nearly 60 feet deep down into competent bedrock to prevent head-cutting erosion from ever impacting the splash pad or the emergency spillway. In the distant future, along with a comprehensive needs study, Oroville may consider a second gated spillway structure here in the emergency spillway area to gain additional control over the water levels at Oroville. Now let's take a closer look at the roller compacted concrete placement here in the emergency spillway. The RCC plant had to be shut down temporarily for maintenance, and this is how they dealt with that.
So this is phase 2 of the emergency spillway, broken into 3 different sections just so they can handle the mass volume of the RCC, because RCC, you got to keep it live all the time, 24/7 operation. And when you break it, here's an example of where they had to break the work and they built this scarf joint here. This will be relivened with a high pressure spray and then poured back into it like they're doing down here. Now the water going down the RCC itself, in the event that they actually ever use this emergency spillway, that water will be flowing at a much lower rate than anything a high pressure sprayer would produce. Each lift is about 12 inches of RCC, and you can see it starts out a very lumpy sort of mixture, and it's kind of soft too. So you can see the steps, the backhoe grades the steps, and then the plate guy vibrates it down into the final shape and hardness. Here's one of the low spots where this water is going to be drained through. And here's how the joint's going to come together. Hell of an amphitheater.
It really cures while we're sitting on it because we want to keep it alive as we raise it up. But if we walk down even to yesterday's lift, it's already set up. We have to do a 14-day water cure on it and keep it moist for 14 days. But it continues to get stronger over time. Design strength's about 3,000 psi, but it'll continue to go past that.
Except at critical attach points, there is generally no steel reinforcement in RCC concrete. It's rolled on like asphalt.
So that's about 2 days old now, or a day? Oh, that's still soft.
Yeah, this is yesterday.
Yesterday,
and then last night we started getting up in here, and so now today they just keep going one lift at a time. Each stair is 2 feet, so it takes 2 lifts to build the bench, and then we step back. Depending on all the grades have been designed, so the step back is anywhere from 5 to 20 feet, depending on where you are within how they want the drain flow to work.
And then the idea is to train it down to 2 low spots and then down the.
Yeah, exactly. There's 2 berms on the very outside that line up with the emergency spillway, so as water would come over the edge of the emergency spillway, it's funneled into the 2 low spots. It controls where the water goes down the slope towards the Thermalito River.
And because this got to be a little bit bigger than the original plan, not only did the cost go up, but you had to import rock for your RCC operation?
We actually have enough. We're making all the rock for the RCC, but that used up any rock that we would use for the wall backfill. And so we're having to make up a small difference of that by importing wall backfill rock. But we're from the quarry, the hillside quarry that we're mining, and also the remainder stockpiles that were dredged from the river, we're making all of the RCC aggregates at our on-site crusher.
And the hillside quarry's right here on site?
Right on channel left, just uphill from the rock crusher.
Gotcha. These are just temporary water berms for construction. They'll be removed later. So because of the lower impact nature of the emergency spillway, the dental work wasn't quite as critical here. You could actually build on dirt as well.
Well, we had to sweep it all clean. So they'll finish up. This is very close to final cleaning here, but they'll come and broom all of the loose rocks off as they work their way up. So this has been preliminary clean. Check out
the purple spray paint indicates more cleaning required. Yeah. Yellow, good to go.
Here's some of that up close dental work. So it's safe to assume this original old OG wall was built on top of this fairly competent bedrock, huh?
Yeah, that's correct. You can see, I mean, it ties into the rock.
Yep.
I think there's a couple areas that had softer rock that the DWR officials were worried about when the event
occurred. The emergency,
where the water was head cutting back towards the emergency spillway.
Right, which was somewhere right in this area, I think.
Yeah,
right over there.
Spot right over there, and there's another one over here we already covered up.
Yep.
It was this erosion that threatened the emergency spillway that caused the evacuation of 180,000 people during the emergency. This is what the new emergency spillway splash pad and secant cutoff wall will prevent.
So Jeff, these square holes we're looking at is part of the original drain structure for the OG wall?
Yeah.
That's where you're going to tie those drains into the rest of your...
Yeah, we connect onto those drains into a header pipe, and it's collected further down in this lowest draw. And then there's a couple where the drains come across the main splash pad surface and just daylight out onto the emergency spillway.
So we won't see a drain system specifically underneath the emergency spillway other than the slots in the secant cutoff wall, huh?
Yeah, the slots in the wall and picking up any drainage from the original emergency spillway, we just collect those. So nothing else added.
And the anchor bolts we're looking at, you just recently drilled and epoxied those in for your Buttress installation coming up soon, huh?
Yep, that's correct. So we pressure washed the entire concrete surface. You can see the color line change towards the top of the curve. And last couple of months we got all the dowel bars epoxied in, ready for RCC buttress.
That looks like something like number 11 or bigger.
Yeah, I think they're number 11 dowel bars.
Yeah. There's the slots for the drains right there.
These slots in the RCC will convey the original drains from the original OG weir and take them out to daylight a bit lower on the RCC splash pad. So operationally, with the reservoir full, we may see some drain water on the emergency spillway. So stay tuned for part 2 of this exclusive boots on the ground report on the reconstruction of the Oroville main spillway and emergency spillway for the 2018 season. In part 2, we'll take a tour of the structural concrete plant, and then we'll go down into the main spillway, interview some concrete, look at some scintillating construction details on the main spillway, and then go down to the bottom and check out what's going on with the rebuilding of the dentates at the very bottom of the spillway. Hats off to all the crew members that are getting this extraordinary engineering job done in record time. See you here.